Welcome everybody. Today we're gonna learn about resistance coils like this one, and they're used in these water heaters. They're very popular in the earth, which is where I live. There are two brands of resistance wires, nichrome and canthal. Nichrome is an alloy composed of nickel and chromium. Nichrome has numbers next to it, like nichrome 40, nichrome 60, and it goes up to 80. And it represents the percentage of nickel present in the alloy. The other popular resistance wire is canthal. Canthal is a combination of iron, chromium, and aluminium. Canthal has a slightly higher maximum temperature and a higher melting point than nichrome, which is why we chose canthal for this build. This particular water heater has two settings, warm and hot. And it needs two resistors to achieve these two settings. The hot resistance needs to be around 10 ohms, this one right here. And we found the canthal wire has about 20 AWG and has about 0.89 ohms per feet. So we need a little bit more than 11 feet of wire to achieve this. The warm resistance is a combination of these two resistances. So for the warm resistance, you need these two in series. This one is 5 ohms and this one is 10. And this one is the one that is used for the hot setting. At a higher ohm value, there is less current. We can use a thinner wire like this one here. And we are using 22 AWG canthal wire that has about 1.6 ohms per feet of resistance wire. If you notice, the same material has two different resistances. This is because the larger cross-sectional area, the lower the resistance, since the electrons have a larger area to flow through. This will continue to apply no matter how thick the wire is. With this power here, we can remember that power is equal to voltage squared divided by the resistance. So in this water heater, in the hot setting, it will consume about 5,760 watts, which is just this resistance. And the warm setting will consume 3,840 watts, which is both of these in series. Also, to find the current, we can divide voltage divided by the resistance. And in the hot setting, which is just with this resistance, is 24 amps. Also, the current in the warm setting with these two resistances is 16 amps. We are going to measure and cut a little more than 11 feet. This is the resistance wire that we are going to cut. For the second wire, we are going to cut almost 4 feet. This is the second wire, and